midpoint theorem. Okay, quickly explain you. Now, what is the statement of midpoint theorem? Let's copy that. This is an important theorem. Okay. Okay, so what does the midpoint theorem say? Okay, what is the main statement of the midpoint theorem? Adam, can you mute yourself? Yeah. Can you mute yourself?
Okay.
Yeah, thank you. Okay, so what does the midpoint theorem say? A line segment joining the midpoints of any two sides of a triangle, okay, is parallel to the third side and equal to half of it, okay? That means if we are going to, the statement says that, suppose this is a triangle, so a line segment joining the midpoint of any two sides of this is the midpoint color. This is the midpoint of the side. First, let me write A, B, C. Okay, and this is E. This is the midpoint of AB, and this is F, which is the midpoint of AC. So this is, wait a minute, A, B, C. Okay, I'm drawing a line segment EF, which is from a midpoint of from one side. This E is the midpoint of AB and F is the midpoint of AC. Okay, so the midpoint theorem says that if a line segment joining the midpoints of any two sides of a triangle, then it will be parallel to the third side. That means EF will be parallel to BC. Okay, and EF will be equal to half of BC. Okay, so we will prove here, okay, this midpoint theorem, and this theorem you will be using in all the questions, okay, and wherever it is joining the midpoints, you can directly write that EF will be parallel to BC, okay, and EF will be half of BC, okay. Now let's see how we are going to prove, okay. First of all, we have to do some extra construction here to prove this result, okay. I'm drawing CD, okay, I'm drawing CD parallel, okay, CD parallel to AB, okay. Understood? This is CD, which is parallel to, I'm drawing in such a way that this is parallel to AB, okay, and it is meeting, this line is meeting here, okay. We have extended EF that joins this CD, okay. Understood? At this point only, this point I'm marking at D, okay. Now let us write what is given here. What is given? We are given a triangle ABC. Yes, triangle ABC, okay, in which E and F are the midpoint of AB, okay, E and F midpoints of AB and AC, okay. Now what we have to prove? What we have to prove here, that EF is parallel to BC and EF is half of BC, okay. Now we have done the construction that we have extended the point C. Actually, we have drawn a parallel line parallel line from C in such a way that it is parallel to BA. Okay, and if we are going to extend EF, then that parallel it meets the parallel line at point D. Okay, now let's see the proof, how we are going to prove. Okay, now you can see here we are going to prove first that this triangle is congruent to this triangle. Any idea how we are going to prove that these two triangles are congruent to each other? See, this angle will be equal to this angle, vertically opposite angle. Any doubt in this?
Ma'am, can I tell? Ma'am, so ma'am, then can we also say that AC is common and then ED is also common?
AC is no, Advika, AC is not common. See, two triangles I'm taking. AC, you are taking the full length. Okay?
Yes, ma'am. So, ma'am, AC is like common for.
Wait, Advika, I'm writing the triangle name here. Triangle AEF and triangle CDF. These are the two triangles that I am taking. Understood? The green portions. Okay. Two triangles are there. What is the fault that I am using same color? Okay. So this is your one triangle. One is with blue color and one is with green color. Now you understood, Advika? These are the two triangles. So AC will not be there. But yes, F is the midpoint. Okay, Advika? F is the midpoint and everybody, yes, F is the midpoint that is given. So AF and FC will be common. AF and FC will be equal. Okay, understood? Now this angle and this angle will be equal to this angle. How this angle is equal to this angle? Anybody can tell me? See, we have drawn CD in such a way that it is parallel to AB. Yes, and this AC is a transverse.
Transverse.
Ma'am,
Okay. Okay.
Yes, Razi?
ma'am, they are parallel. Some are alternative angles.
Yeah,
Alternate angles.
alternate angles. Okay, so we have already got angle ASA, angle ASI, and angle ASA. From ASA rule, we have proved that the triangles are congruent. Let me write all the values. Okay, AFE, angle AFE is equal to angle DL. Oh, sorry, not D, C. CFD. Yes, they are vertically opposite angle, vertically opposite angles. Okay. Now, AF is equal to CF. F is midpoint, or you can write it is given. Okay. And which angle? EAF. Angle EAF is equal to angle DCF. DCF. Okay. Alternate angles. Alternate angles. So, okay. Therefore, triangle AEF is congruent to triangle CDF. Okay. So now, why we have proved these two triangle congruent? What is our motto to prove this? These two triangles congruent. Now, as we have proved that these two triangles are congruent, so we can say that this CD is equal to AE. CD is equal to AE from CPCT, and EF is equal to FD from CPCT. Okay, so
Yes, sir.
AE is equal to CD, and EF is equal to FD. EF is equal to FD from CPCT. Okay, understood? Now, how we are going to use? Now, we have seen that AE is equal to CD, and we already know that E is the midpoint of AB. So AE is equal to EB. AE is equal to EB. This is given. Okay. So from here, you can name it an equation first. Okay. From first and second. What we got? That AE is equal to EB is equal to CD. Okay. All the three are equal. So actually what we got, that these two are equal. That is EB. Okay, I'm just drawing that much portion only. Okay, rest portion for time being you neglect. Okay, okay, this is the portion, and we have this. Okay, upper top I'm just for time being I'm leaving. Okay, so we have got that this is equal to this. Yes, we have already got that EB is equal to CD, and from construction we know that EB is parallel to DC. Yes or no? EB, any doubt?
No, ma'am.
Anybody, any doubt? From construction, we have drawn this CD in such a way that it is parallel to AB. Okay. So if you remember in the parallelogram, in the quadrilateral chapter inside the parallel properties of parallelogram, we have studied one theorem that if one of the sides of a parallelogram is equal and parallel, then it is a parallelogram. Okay. So therefore, you can mention here third and no, not this third. From wait, I have to write here parallel from third and fourth. What we have got, that BCDE is a parallelogram. Understood? Any doubt till here that why BCDE is a parallelogram? Because one of the side of this BCDE, one of the sides are parallel and equal. So we can say that it is a parallelogram. Okay, we have already proved this theorem. Okay, when we were studying the properties of the parallelogram. Understood? Now, since it is a parallelogram, that means BC will also be parallel to ED and BC will be equal to ED also. Yes or no? Okay.
Yes, ma'am.
Therefore, BC will be equal to ED and BC will be parallel to ED also. Okay. Now, since BC is equal to ED, okay, ED, but we have already seen that EF is equal to FD. Okay. So you can write this ED. Okay. BC is equal to ED can be distributed into ED. The whole ED is equal to what? EF plus FD. EF plus FD. Okay. So we can write EF plus FD. Okay. Now from we have proved here na, from equation EF and FD. Yeah, from equation first Okay, we have already seen that we can write EF plus EF. Okay, so BC is equal to 2EF, or you can say that EF is equal to half of BC, and EF is parallel to BC also. EF is a part of ED. So if a part of a parallel line also you take, so that is also parallel. Okay, understood? Advika, Shazan, Razi, Arham, and Arham, you have one colleague.
I'm saying this.
Repeat, please, Arham. I didn't hear you, Arham.
What, ma'am?
What's her name?
Ridhima.
Ridhima. Okay, very next name. Okay, so understood, Ridhima? Any doubt?
Yeah, understood.
Okay, that's very good. So everybody else understood this theorem, midpoint theorem?
Yes, ma'am.
Okay, so we have covered midpoint theorem. Now we will be seeing the converse of midpoint theorem, and then we will be seeing the question. You will get the question based on this. Okay, and this midpoint theorem is important because sometime in your exam you will get directly midpoint theorem. Okay, the statement will be there, this statement, the line segment, and you have to prove it. Okay, and sometime you will get the direct question on it also. Okay, so now what does the converse of midpoint theorem say? The converse of midpoint theorem says that the line drawn through the midpoint of one side of a triangle and parallel to the another side bisect the third side. Now this time it is only given that AE is AE is equal to EB. Okay, let me copy. Okay, now what is given here? That AE is equal to EB and EF is parallel to BC. Now we have to prove that F is the midpoint of AC. Okay, now this time also we'll go with the same steps. Okay, little bit. Okay, so what we are going to do, we are going to do the same construction. We are going to draw CM parallel to AB. Okay, and EF will be extended and it will be joining CM at a point D. Okay, understood? Now again we are going to take the two triangles, that is AEF. Okay, this is AEF and EFD. Okay, these two triangles we will be taking, but this time we will be having something different because AF is equal to FC we don't have. Now from CPCT we will be proving that AF is equal to FC. Okay, yes or no? Now, so what are the points that we can by which property we can say that these are equal, these two triangles are congruent? See,
Can we use SAS?
SAS. Which two sides you will be taking, Shazan?
Ma'am, AE and DC.
AE and D. I'm talking about these two triangles. These two triangles.
Oh, that got it.
Is it not visible? Your net is not strong. If that diagram is properly visible, na Shazan?
Ma'am, that I can see the diagram.
Yeah. So wait, it is distracted now. One is the green color diagram, that is AEF. One triangle. The first triangle is AEF, and the next triangle is CDF. Okay.
Ma'am, I can see a big triangle, ma'am, ABC. That one, and ma'am, what is
You
this?
cannot see two colors there.
No.
Try to exit the session and re-enter.
Okay.
Everybody else can see. Yeah, no? Okay. So here what we can do, yeah, very good. That this angle is equal to this angle.
Yes, ma'am, I can see.
Alternate angles. Okay, because CM is parallel to AB and AC is the transversal. So this angle A will be equal to angle C because they are alternate angles. Similarly, this angle will be equal to this angle. Again, the two lines are parallel and this is a transversal. Okay, so these two lines are also parallel. Now CD will be equal to AE. How CD is equal to AE? Because here BECD is a parallelogram. Okay, why what I'm saying, BCDE is the parallelogram. Okay, and we already know that if it is a parallelogram, so BE is equal to CD. Okay, and E is the midpoint, so BE is equal to EA. So from there we conclude that AE is equal to CD. Any doubt?
No.
Okay, so we have CD is equal to AE. So we got three things, that is ASA. Okay, so from ASA rule, we have proved that the two triangles AEF is congruent to triangle CDF. Okay, now from, as we have already proved that the two triangles are congruent, so from CPCT AF is equal to FC. So F is the midpoint of AC. Understood? Understood?
Yes, ma'am.
Yes, ma'am. Understood.
Okay. So this is the converse of the midpoint theorem. Okay. And we have seen the midpoint theorem also and the converse of midpoint theorem also. In the midpoint theorem, E and F will be the midpoint that is already given to you, and you have to prove that EF is parallel to BC and EF is half of BC. Okay. And in the converse, it is given that E is the midpoint and EF is parallel to BC, and you have to prove that F is the midpoint. Okay. But when the theorem comes directly, then you are going to show the whole theorem. But in the question, if E is the mid, it is given that E is the midpoint and EF is parallel to BC, so directly you can write from converse of midpoint theorem, F will be the midpoint. Okay. And yeah, Advika, you generally ask that what a statement will mention. You don't have to write the whole statement, and everybody else also, you don't have to mention the complete theorem. You just have to write from midpoint theorem, from converse of midpoint theorem. Okay. Now let's see the questions based on this. Okay. Now question number 1, let's copy. Now what is the question here? ABC is an equilateral triangle. We have an equilateral triangle of ABC. 3 sides are there. Okay. ABC. I'm mentioning ABC. Okay. Now L, M, and N are the midpoints of the side AB. So midpoint of AB is L. Okay. And midpoint of BC is M. This is L. This is M. And CA is N. Okay. Now, respectively, prove that LMN is an equilateral triangle. Okay. Now, we have to prove that LMN is an equilateral triangle. Okay. You will be writing given here. What is given? What is given here? That triangle ABC and LMN are midpoints of AB, BC, and CA. To prove triangle LMN is an equilateral triangle. Okay. Now prove. Think about it. I am coming back in just 2 minutes. Okay. Understood? Just think about it, how you're going to prove that LMN is an equilateral triangle, and then we'll see. So any idea how you're going to prove that LMN is an equilateral triangle?
And we could just prove like ALN and LBM, like we can prove that they're congruent.
That they come to?
What one?
Yes, ma'am. We have to prove that those 3 triangles are congruent, and then by CPCT we can say that.
Yes, by CPCT we can say the triangles.
Try to use your midpoint theorem. Try to use midpoint theorem. It will be more easier.
Okay, ma'am.
See, you have 3 sides, and in 3 ways you are going to take the triangle. Okay. See, one way you will be taking this triangle. Okay. ABC. From in ABC, L is the midpoint of one side AB, and N is the midpoint on one side AC. Yes. Yes or no? So
Yes,
if a
ma'am.
line segment joining the 2 midpoints of 2 sides of a triangle, then it will be parallel to the third side and it will be half of the third side. That means from midpoint theorem, Ln is equal to half of BC. Any doubt here? No? Now you take the triangle BAC. Okay, BAC. I'm using another color. Which color I use? Okay. Now in BAC, you take this as a tip. Okay. Now L is the midpoint and M is the midpoint. This is the midpoint. Okay. So therefore LM will be half of
Half
AC.
of AC, yes, sir. And then on that way, NM will be the half of
Yes, very good,
BA.
Advika. Half of
B.
AC and which one? MN. MN will be half of AB.
B.
Okay.
AB.
And we know that since ABC is an equilateral triangle, therefore AB is equal to BC is equal to CA. So half of AB will be equal to half of, we are multiplying this equation with half, dividing this equation with
Ma'am,
half.
will it half AB equal to half BC equal to half CA?
Yes, that
Ma'am,
is
but
the
still,
half
ma'am, just because
AB.
these
And then-
3 sides are half of each other, ma'am, like, is
Ma'am,
it given that
MN
triangle ABC is congruent? Is an,
wait.
sorry, is an equilateral triangle?
Yeah, Advika, can you repeat?
Ma'am, is it given that ABC is an equilateral triangle?
Yes, it is given.
Okay, okay.
The first thing that was given, the question was that ABC is an
Yes,
equilateral
sir.
triangle.
Equilateral. Forgot to
Okay.
note that. Yes, sir.
Else it would be very tough to prove. Okay. Not tough, in a different way we can prove, okay, that this is the midpoint, but still how can you say that these two will be, okay? So something else will be given that, okay, so half of AB, half of BC, half of CA will be also equal, so half of AB will be MN is equal
Ma'am, Mn equal to Ln equal to Lm.
yes, L.
Then we can write, ma'am, hence triangle LMN is an
Therefore,
equilateral.
triangle LMN is an equilateral triangle, okay, hence proved. Any doubts?
Oh, ma'am.
Razi, have you understood?
No, ma'am.
Razi, are you there?
Yes, ma'am.
Now think about this question also, and you already know we are going to for now we are going to use the midpoint theorem or the converse of midpoint theorem. So in that way you think and try to solve it. How we are going to do? So first of all, what is given? E and F are respectively the midpoints of a non-parallel sides AD and BC of a trapezium ABC. Now first of all, let us draw a trapezium. So trapezium is in this way, okay? So E and F are respectively the midpoints of non-parallel side, that is E and F, because these are non-parallel sides, non-parallel sides of AD. E is the AD, and F is of BC. Okay, trapezium ABCD. Prove that EF is parallel to AB. Now you have to prove that EF is parallel to AB and EF is half of AB plus AC. It is similar to your what we have done proof. So here we will do little bit of construction.
Yes, ma'am. We will join DF.
Yeah.
Ma'am, we'll join DF.
We will join.
Ma'am, we'll join the points D and F.
You will be joining. No, not D and F.
Ma'am, I've done like that only.
You have to show that half of AB plus CD na. So
Yes, ma'am. I know those.
you are saying D, E, you have joined.
No, D and F.
Okay. See, I am doing this way. And if you are saying D and F, after joining D and F, what you will do?
Ma'am, but my F is at like over there. Means I have done. Ma'am, my construction is a little bit different. Like my parallelogram is also different.
Send me your proof, okay? Then I will check, okay?
Yes,
Because
ma'am.
it's not necessary that it is only, I always tell in mathematics, you don't have only one way to solve the question, okay?
Okay.
Yeah, it's
I'm
not that.
sending the picture of this.
Yeah. So
Okay.
we are doing construction in such a way, okay? So what we are going to do, see, you see this triangle, okay? So if you see this triangle, in this triangle, what we can do, we can apply midpoint theorem, okay? What happened? Or the converse of midpoint. Okay. Now, E is the midpoint, F is the midpoint. Yes, E and F are the, it's given, na? No, E is the midpoint of AD. It is given midpoint of AD. Okay, it is not given that it is the midpoint of, you extend it to C, D, E, F, G. Okay, write down G. Okay, so yes, if we are able to prove that E is the midpoint of BG, okay, if E is the midpoint of BG and F is already given that it is a midpoint of FC, okay, so we can say that EF is half of if half of GC and EF is parallel to GC, yes or no?
Yes, ma'am.
Okay, I'm talking about the triangle BGC. In triangle BGC, if we are able to prove that E is the midpoint of BG and F is already given that it is a midpoint of BC, so we can say that EF is the EF from midpoint theorem. EF is half of GC and EF is parallel to GC. Okay, and we will so we have to prove that EG is equal to EB. Okay, so what we are going to do, we are going to take again two triangles, these two triangles, this triangle and this triangle. We are going to take this triangle. Okay, okay, in these two triangles we will prove that it is congruent and then we will show that this is equal to this, okay, and this this is equal to this, so that we can prove that it is half of AB plus CD. Okay, because if you are able to prove that E is the midpoint, so we can say that EF is half of GC. Okay, so if we will prove that GD is equal to AB, so it will be half of AB plus CD. Understood? Now let's prove that these two triangles are equal. That is GDE is equal to BEA. Okay, so here these are alternate angles. Somebody saying something?
We can use ASA.
ASA. Okay, so which two sides you will be taking?
DE and AE.
ASA. Yeah, ASA we will be using. Okay, so this one angle will be this, and another angle will be this. Yes, because these two lines are parallel, and this is a transverse. Okay.
EDG and EAB can be equal because they are alternate interior angles.
Yes. Which one you're saying? EDG.
Yeah, and EAB.
Maybe this one also you can take, okay, because these two lines are parallel and this is a transverse. You can take these two lines also, these two angles also, and this side. In fact, this angle only you take, okay, because this will be little far, okay. This angle and this side you will be taking because E is already given. It is a midpoint, okay. So AE is equal to ED. Any doubt, anybody? ASA angle, right? BAE is equal to angle GDE, okay, alternate angles, and angle GED is equal to angle BEA, okay, BA. These are vertically opposite angles, and AE is equal to ED. It is given, okay. So triangle GDE is congruent to triangle BAE. Any doubt in the congruency of both the triangles?
No, ma'am.
Okay, so if both the triangles are congruent, so we can say that therefore GE is equal to BE and GD is equal to AB from CPCT. Okay, so these two triangles are congruent. So therefore E is the midpoint of BG. Okay, so from midpoint theorem, EF will be parallel to CG and EF will be equal to half of CG. Okay, and CG can be written as half of CD plus DG. CD plus DG, and DG can be mentioned as AB. Okay.
So I'm basically using the midpoint theorem, right?
Yes. Right now we have studied midpoint theorem. We are using midpoint theorem. So from midpoint theorem, we have proved that it is half of CD plus AB. Any doubt in this?
No, ma'am.